This video will be part 2 of lesson 3, and it is on page 160 of your student workbook. The corresponding podcast that you could watch for extra clarification is Unit 226 from the YouTube Mac Prima. Okay, what I would get you to star is I would star this, or not necessarily star this, I would just write notes. So I'm going to be explaining this as we go through the class examples, but if you needed to sort of look back and figure out step by step what I was doing, this would be the notes that you're referring to. What we're going to be dealing with in this lesson, again, is we're going to be looking at the cast rule. So step 1 in all of these questions says determine the quadrants the angle will be in by looking at the sine of the ratio. So for example, if they gave me sine of theta is 0.5 and they said, well, what quadrants could I possibly be in? You would say, okay, according to my cast rule, um, you'd put a check mark in the two quadrants where sine is positive, right? And those two quadrants where sine is positive is here or here. And then from there, we would determine, are they going to further restrict my answer to tell me, okay, you're in quadrant 1 or you're in quadrant 2, or we could potentially have two answers. So again, these steps I will go through as we're going through the class examples. One of the things that's really important is this note here. And what they're writing, they're writing the domain. So and what they're doing is they're what's called restricting the domain. So this is from 30-1, but you will see it in 20-1. So what they could say is they could say, okay, they want theta, and theta is basically your answer, to be less than 180 but greater than 0. So where would your solution be if theta was less than 180 degrees but greater than 0 degrees? What you would say is you'd say, okay, 180 degrees is right here, 0 degrees is here. So less than 180 would be that, and greater than 0 would be here. So my solution is in quadrants 1 and 2, right? Let's say they gave you this domain here and they said, well, where would the quadrant be for this solution? So, okay, the solution, or theta, they're saying is less than 180. So less than 180 would be there. But then they're saying it's greater than 90. Greater than 90 would be in this direction. So less than 180, but greater than 90, my answer would be in quadrant 2. So again, this is called restricting the domain, and you need to be able to read this in order to figure out where your solution is. So according to this domain restriction, I could have two solutions in quadrant 1 and quadrant 2. According to this domain restriction, my solution would be in quadrant 2. Okay, so what this first question says is use the procedure above to solve the sine of theta is equal to 0.5. Always draw your cast. C-A-S-T. And then put a check mark in the two quadrants where sine is. Now, is this a positive or negative number? So 0.5 is a positive number. So I would put two check marks in where sine is positive. And sine's positive in quadrants 1 and quadrants 2. And then they're saying they want the domain to be from negative 360 to 0. So what that means is they want the domain, this is 360 degrees, and this is 0 as well. So they want my solution to be less than 360, but greater than 0. So basically, my domain is anywhere in quadrants 1 to 4. So I'm going to have two solutions, right? Because sine is positive in these two quadrants. Okay, how would you have done this from grade 10? If I said from grade 10, what is theta? What you would have done is you would have taken the inverse sine of the ratio. So the sine inverse of 0.5 that is going to give you what theta is equal to. So on my calculator, clear this, make sure you're in degree mode. So again, type in, to double check, type in the sine of 90 and you should get 1. So we're in degree mode. So to figure out what degree this is, what's my angle, I'm going to type in second function sine of 0.5. So second function sine of 0.5. And I get 30 degrees. So let's write that down, 30 degrees. What you need to know that is super, super important is whenever we are calculating that angle, the answer that we get is always the reference angle. So the answer that we get when we're figuring out this angle, it's always the reference angle. So then what we do is we put that reference angle, we know that we have a solution in quadrant 1 and we have a solution in quadrant 2. So I'm going to go ahead and I'm going to put my terminal arm in quadrant 1 and my reference angle is 30 degrees. So I'm going to put 30 degrees there. And I know I have a solution in quadrant 2. So I'm going to put a terminal arm in quadrant 2 and my reference angle is 30 degrees. Now, what the question is actually asking is, based on this reference angle, they want to know what were these two angles in standard position, or the two rotational angles. So in quadrant 1, my solution, remember that the reference angle is equal to the rotational angle. So one of my solutions is 30 degrees. The other solution is in quadrant 2, and they want to know what is the rotational angle. So this would be the rotational angle there. What angle is that? Here's 180 degrees. 180 degrees minus 30 degrees would give you 150 degrees. So that second answer, because remember I had two answers, it's 30 degrees and 150 degrees. Could you check this? Yes. We just got that theta is 30 and theta is 50. If you wanted to check this, you could type on your calculator the sine of 30 degrees, and you could type in the sine of 150 degrees. And let's see if we get 0.5. So the sine of 30 degrees and the sine of 150 degrees are both 0.5. Okay, let's do class example 6 now. So for class example 6, they want to know what angle x is if the sine of x is equal to this trig ratio here. So draw your cast. Okay, so we always, it's going to be the same thing, you guys, over and over, every single question. Then say to yourself, was this ratio positive or negative? So this is a negative ratio. Put a check mark in the two quadrants where sine is negative. And I hope you said quadrants 3 and quadrants 4. So now what we have to do is we have to find what is our reference angle. So to find the reference angle, we take the inverse sine. Now, here's where this is important. So I would have talked about this in 10C, but you might have forgotten. When we are finding our reference angle, we always take what's called the absolute value of this number, which is the positive. So whenever we're finding an angle, we will never write the negative. So instead of negative 0.8090, you always write just what the positive value is, 8090. Okay, so like when I find this angle, and I'm going to type in the second function cos, I'm going to omit that negative. And same with tan. You always type in the positive value when you're finding the reference angle. So I'm going to go to my calculator. I'm going to clear what I have from the previous question. And I'm going to find the inverse sine of 0.8090. So 8090. And I get, they want it to the nearest degree. So I'm going to write 54 degrees. Now, remember, that is always your reference angle. So the number that spits out, it's always going to be your reference angle. So what you then do is you then say, okay, I had two solutions and my solutions were in quadrants 3 and in quadrants 4. So I'm going to draw a terminal arm in quadrant 3 and I'm going to draw a terminal arm in quadrant 4. The reference angle for both of these is 54 degrees. Remember, you could make a triangle, right? So my reference angle is 54 degrees. They want the angle in standard position or the rotational angle, which would be this guy here. So how do you get that angle? It would be 180 degrees plus 54 degrees. So if you do 180 plus 54, my first solution, 180 plus 54 is 234 degrees. So that first rotational angle is 234 degrees. So I'm going to write x is equal to 234 degrees. Then I need to find out what this rotational angle would be. So once around the circle is 360 degrees. 360 minus 54 degrees will give you a rotational angle of 306 degrees. Again, let's check on our calculator. Let's type in the sine of 234 and the cos of 30, or sorry, sine of 234 and the sine of 306. So the sine of 234, negative 0.8090, and the sine of 306. And I get that same answer. I want you guys to draw your Cartesian plane for B. Put your check mark. It's always going to be in two quadrants where cos is negative. So cos is negative here and here. So that means I'm going to have a solution in quadrant 2 and a solution in quadrant 4. I need to figure out what this rotational angle is and what this rotational angle is. In order to do that, I need to figure out my reference angle. So my reference angle, it's the inverse cos of the positive value of that number. So second function cos of 0.8090. My reference angle is 36 degrees. Theta r is equal to 36 degrees. Where would you write 36 degrees in each of these two? Where would you do it? So you need to, if you need, draw your little triangles. 36 degrees would be right there. And in here, 36 degrees would be there. So how do we find the rotational angles based on those reference angles? The first rotational angle would be 180 degrees minus 36. And you should get 144 degrees. That rotational angle is 144 degrees. My second solution, if this is 180 degrees and I'm adding 36, so here I'm going 180, this is 180, and then I'm adding 36, I would get a rotational angle of 216 degrees. Okay, let's do C. Draw your Cartesian plane, label cast. Put a check mark in two quadrants, and the two quadrants are going to be the two quadrants where tan is negative. So where is tan negative? Here's tan's negative, and here. So I'm going to have one of my answers is going to be in quadrant 2, and I need to figure out what that rotational angle is. And one of my answers is going to be in quadrant 4. I need to figure out what this rotational angle is. In order to do that, I need to get my reference angle. So the inverse tan of the absolute value. Absolute value, you guys, it's always the positive number. So that would be 2.4586. Second function tan of 2.4586. This would round, if we were to do to the nearest degree, 68 degrees. And remember, what did I always say that is? That's your reference angle. So now you have to go to these two solutions and put in a reference angle of 68 degrees. So that always goes into your triangle. So you have to find out where the triangle is, right? The triangle is always from the terminal arm to the x-axis. This would be 68 degrees. On my second one, from the terminal arm to the x-axis, there's my acute triangle. This would be 68 degrees. So my first solution to figure out what theta would be, or sorry, what x would be, so this angle here, 180 degrees minus 68 degrees. And if you do 180 minus 68 degrees, you should get 112 degrees. So that angle there, angle x is 112 degrees. So my first solution, my second solution, one complete rotation is 360 degrees. I'm going to subtract that reference angle of 68 degrees. 360 degrees minus 68 degrees. Just trying to think, sorry, did I make a mistake somewhere? 368, there's a mistake in the book. So let's check. 360 minus 68. 360 minus 68. 292 degrees. I just want to double check that I did this one right. So 180 minus 112. Let me just double check that. 180 minus 112. Oh, sorry, 180 minus 68 it should be. 180 minus the reference angle of 68. Yeah, 112. Okay, those would be your solutions. We've got two more class examples. Okay, class example 7. The sine of theta is equal to 1. So again, you guys, same thing, over and over and over. Sine of theta is equal to 1. Actually, sorry, we are not going to do class example 7. I'm going to do this in lesson 4. We will do class example 8. Okay, solve this equation here. So in all of my previous examples, I had, for example, when we were solving, if I just go back here, I had the sine of theta was equal to something, or the cos of theta was equal to something. Basically, my trig ratio was isolated. If you go to class example 8, this trig ratio is not isolated. So what we have to do is we have to isolate this. How we isolate it, so just let me show you. This would be sort of the same thing as, instead of tan for now, I'm going to take out tan and I'm going to put in the letter x. So this would be the same thing as saying 3x plus 1 is equal to 4. If I said solve for x, how would you do that? You would subtract 1 from both sides to get 3x is equal to 3, and then you would divide to isolate x and say x is equal to 1. We're going to do that exact same thing, except we're going to isolate tan of theta. So get rid of that plus 1 by subtracting 1 from both sides. Then we get 3 times the tan of theta is equal to 3. From here, let's get rid of that 3 by dividing both sides by 3. And we would get the tan of theta is equal to 1. Okay, let's draw our cast rule. C-A-S-T. Put your 2 check marks. Where do you think the check marks are going to go? They're going to go in 2 quadrants where tan is positive. So where's tan positive? In its own quadrant, T, and all trig ratios are positive there. So what I need to do is I need to find, I've got 2 solutions, and my solutions are in quadrant 1. So I need to find out what that rotational angle is, and in quadrant 3, I need to find out what this rotational angle is. In order to do that, we need to find what the reference angle is. So the inverse tan of 1 is equal to, so second tan of 1, 45 degrees. Now, what was 45 degrees? That number is always your reference angle. So go to your 2 solutions, your terminal arms. Let's make our triangles, and let's put our reference angles of 45 in there. Okay, so now that I've got my reference angles of 45s in there, I could find what my oh, okay. I just realized that the domain is restricted. So I'll get my 2 solutions, and then one of them I'm not going to use as an answer. So my 2 solutions, theta is equal to, so this angle, remember when we're in quadrant 1, the reference angle is equal to the rotational angle, so 45 degrees. And in quadrant 3, this is 180 degrees. So 180 degrees plus 45 degrees would give us, so let's see in quadrant 3, 180 plus 45 degrees would give me 225 degrees. So at first, you guys, I was going to box this in and say 2 solutions, right? Those would be my 2 answers. However, I didn't realize we always have to look and say, did they restrict the domain? And they did. Here is a domain restriction. So they want my domain to be less than 180 degrees. So that's less than 180, but greater than 0. So they want my solution to be somewhere in here. So according to these 2 answers, which one do you think the answer would be? 45. That's the only answer that is less than 180 degrees but greater than 0. So there's actually only one solution for this, and theta would be equal to 45 degrees. Okay. For your homework, these are the questions I want you to do. 10, 11 ABC, 11 DEF, and I think I've got it starred because I'll probably set it up for you, and 14 to 18. Okay, so let's look at question 11 and see why do I have that starred. Oh, okay, here's the reason why. So 11 is like the class example that we just did. And what you have to do is you have to isolate your trig ratio. So for D, it's 6 times the sine of theta because they're next to each other. That operation would be multiplication. So the opposite of multiplying by 6 would be dividing both sides by 6. So sine of theta is equal to negative 1 over 6. Remember, according to the cast rule, where would you put, which two quadrants would my solution be in? Sine, they're telling me, is negative. So these are the two quadrants where sine is negative. I'm going to have one solution here, and I'm going to have one solution here. We need to get what the reference angle is. So you need to calculate the inverse sine of the positive value of this, which is 1 over 6. Second function sine of 1 divided by 6 gives me a reference angle of 10 degrees, it looks like. Let me make sure I'm doing this right. Yep, reference angle is 10 degrees. Theta r is equal to 10 degrees. Do they want this to the nearest degree? Yeah, to the nearest degree. So then you have to put your reference angle in. In order to do the reference angle, you need your two triangles. So that would be 10 degrees, and this would be 10 degrees. The rotational angle would be this one. So 180 plus 10, I'm hoping that you'll see is 190 degrees. So that first solution, and then the second solution, they always want the rotational angle, which is this. If this is 360 degrees and I subtract 10 degrees, the rotational angle would be 350 degrees. Okay, so for the next two, I won't completely solve it. I'll just make sure I'll help you set it up. If we needed to isolate cos of theta, get rid of that -3 by adding 3 to both sides. And we would get 4 times the cos of theta is equal to 3. Divide this by 4, divide this by 4. Cos of theta is equal to 3 over 4. Just to quickly double check, where is cos positive? Everything's positive there, and there's cos's quadrant. So I'd have my two solutions would be in quadrants 1 and quadrants 4. Find your reference angle and see if you get those two solutions. For f, tan of theta is -5. Where is tan negative? Here and here. And remember that you need to find the inverse sine of the absolute value of -5, which is 5, and get that reference angle. Put that reference angle in quadrant 2, put that reference angle in quadrant 4, draw your triangles, and see if you could figure out the rotational angles.